The amount of municipal solid waste in many of the world's major cities will rise in the coming years. As a result, large controlled landfills are increasingly replacing uncontrolled landfills. Waste here is usually shredded and compacted. Anaerobic zones form inside the landfill body. The problem is methane is generated from biodegradable waste within the anaerobic zones. The climate impact of methane is 25 times greater than that of carbon dioxide. To prevent the uncontrolled emission of greenhouse gases, the landfill gas must be captured and the landfill covered up. Landfill gas with a low concentration of methane is flared. If the landfill gas has a higher methane concentration, it is suitable for heat and electricity production. However, only half of the landfill gas can be captured. The rest escapes into the environment over time. To keep climate damage at a minimum, the least possible amount of biodegradable waste is allowed into the landfill. In addition, reusable material should be recycled. For that, good separate waste collection at source is essential. Recyclables such as metal, glass bottles, paper, cardboard, and plastics can be collected separately or mixed. After sorting and other pre-treatment, the recycling materials are further processed in industry. That saves the total amount of energy and raw materials needed for further production. Recycling 1 ton of glass saves about 500 kilograms of CO2 equivalent. 1 ton of paper saves up to 800 kilograms, and 1 ton of sorted plastic saves a hefty 1,500 kilograms of CO2 equivalent. Even the organic part of household waste, such as kitchen and garden waste, can be separately collected at source. In a digestion plant, bio-waste is converted into biogas under anaerobic conditions. The methane-rich gas is collected in large containers and its energy is recovered. That saves fossil fuel and protects the environment. The digestate can then be composted and made available for reuse in agriculture. Separately collected bio-waste can also be used directly for composting. The compost is applied to crops or to home gardens. The remaining mixed or residual waste can be treated in a mechanical biological treatment plant. Impurities and high calorific fractions can be separated out in the mechanical section of the plant. The organically rich component can be treated aerobically or anaerobically in the biological part of the plant. Anaerobic digestion allows for energetic use of the biogas in order to generate heat and electricity. The high calorific fraction, which is mainly composed of plastics, can serve as refuse-derived fuel in power plants and cement kilns, thereby replacing fossil fuels. Waste from the mechanical biological treatment plant is deposited in a landfill. Since the biodegradable components are largely reduced, the landfill volume is minimized, and the waste emits hardly any methane at all. Instead of mechanical biological treatment, the residual waste can be used energetically in a waste incinerator. That also saves fossil fuels and protects the environment. Global waste management is one of the biggest sources of anthropogenic greenhouse gas emissions. Landfill gas collection and energetic recovery. Separate waste collection at source. Substitution of energy-intensive raw materials. The use of biodegradable waste as compost and a source of energy production. The treatment of residual waste in a mechanical biological treatment plant, or by incineration. These are the building blocks of an integrated waste management to protect our planet from global warming.